All right, let's dive right in. For as long as AI has been a thing, we humans have been the ones designing it. But what if that's about to fundamentally change? We're talking about a completely new way of doing science, where the scientist, the one actually coming up with the big ideas, isn't human at all.
To really get your head around how big a deal this is, you just have to look at how the researchers themselves talk about it. They compare this moment to AlphaGo's Move 37. You know, that move that was so creative, so alien, it literally rewrote the book on how to play the game of Go. And that really is the heart of the matter, isn't it? What happens when an AI starts having those kinds of brilliant insights that its own human creators couldn't even see coming? And look, this isn't some far-off sci-fi concept. It's happening right now. So let's really unpack what this Move 37 moment for AI research looks like. Because it's not just about building a smarter AI, it's about completely changing the engine of innovation itself. The whole thing starts with a bit of a mystery. Out in the wild world of AI research, there's this new designer that's just pumping out these incredible new AI models. And the crazy part? They're consistently better than the ones made by the best human experts in the field. But you might be wondering, why is this even a big deal? Why do we need an AI designer anyway? Well, it's because we've hit a wall, a massive bottleneck in how we do research. Here's the core problem in a nutshell. On one side, you have AI's potential, which is just shooting for the moon, growing exponentially. But on the other side, you have the actual research, the human process of thinking up new AIs, and that's stuck in the slow lane. It's limited by human speed. And that creates this huge, widening gap. And to put a number on it, just think about this. A single cutting-edge AI model can take a whole team of brilliant people about 2,000 hours to design. That's months of work for just one new idea. It's just not a process that can scale. So with a bottleneck like that, how do you break through? Well, the answer is to just throw out the old playbook and try something completely different. So that mysterious genius designer we were talking about, it turns out it's not a person, it's not a team of people, it's a fully autonomous AI system. And it's called ASI Arch. ASC Arch stands for Artificial Superintelligence for Architecture Research. And this represents a huge shift in thinking. We're going from AIs that just get better at tasks we give them to an AI that can actually conduct its own scientific research to invent entirely new kinds of AIs. I mean, this is just incredible stuff. But how does it actually work? How does an AI do science from start to finish? The secret sauce here is that AC Arch isn't just one monolithic AI. It works like a tiny, super efficient research team. You've got the researcher agent that comes up with a hypothesis, then the engineer agent codes it up and runs the tests. The analyst pores over the results to find insights, and the cognition base remembers everything, making the whole team smarter for the next go-around. It's a non-stop automated research lab. Now, to make sure the AI is actually creating better designs and not just weird ones that happen to score high on a test, it's guided by this really clever idea called a fitness function. It's not just about raw performance, it also factors in the architectural quality. Basically, another AI acts like an expert judge, rewarding designs that are elegant, new, and well-structured. It pushes the system towards genuine innovation. So that's the setup. It's a beautiful idea, but the real question is, does it work? Well, this is where we see the absolutely mind-blowing results. The researchers found something that is, frankly, a game changer. They established the first ever scaling law for scientific discovery. What does that mean? It means they prove that you can get more scientific breakthroughs just by adding more computing power. Discovery itself has become a scalable process, and they really put that idea to the test. They threw a ton of compute at this thing. Over the course of the experiment, ASI Arch chewed through 20,000 GPU hours. And what did they get for that massive computational investment? The system, all on its own, discovered 106 brand new, state-of-the-art AI architectures. Now, let's put that in perspective. At 2,000 hours each, that's a feat that would have taken a human team more than 24 years of working around the clock. And look, these weren't just a bunch of random designs. The models the AI came up with, like Pathgate Fusion Net and Content Sharp Router, didn't just compete with the human-made ones. They systematically outperformed them on really tough reasoning tasks. The AI wasn't just faster, it was actually better. Okay, so let's just zoom out for a second and really think about the implications here. What does this mean for, well, everything? This is maybe the most fascinating part of the whole thing. We get a little peek inside the AI's mind. When you look at its best designs, sure, almost half of the inspiration comes from existing human knowledge. But nearly just as much, about 45%, comes from the AI analyzing its own experiments. And then there's the small but critical sliver of pure originality.
And that reveals something pretty profound, doesn't it? You can learn to be competent by studying what others have done. But to achieve real excellence, the kind that leads to breakthroughs, you have to do more. You have to learn from your own journey, from your own trial and error. The AI hit its stride when it learned to learn from itself.
Which leaves us with this final massive question to chew on. If AI can now accelerate its own evolution, what in the world happens when the pace of discovery is no longer tied to the pace of human thought? We might be entering an era where innovation scales with computation itself. And where that leads is anyone's guess.